For decades, we've basically been training our bodies, well, our thumbs really, to speak to machines. We all learned this intricate language of typing and swiping, a very structured input designed for very structured interfaces. But I think if you've been using generative AI lately, you'll know that era, that thumb epoch, is, well, it's quickly coming to an end.
It is, and it's a really profound transition. This is so much more than just dictating instead of typing. The old way, the keyboard era, was all about operating software. We had to fit into the machine's world, filling out forms, clicking through menus, learning very specific commands. What's happening now is a fundamental shift in that dynamic. We're moving from operating machines to simply expressing our intent.
Expressing intent, that's the phrase.
And we're letting the systems do the messy work of figuring it out.
That distinction, operating versus expressing, is exactly what we're going to unpack in this deep dive. Our mission today is to look at why speaking to AI is becoming the default, how big players like Google and OpenAI are turning conversation into computation, and, critically, the one massive catch that threatens to limit this whole revolution for millions of people around the globe. And that's the persistent problem of multilingual equity.
Exactly. We've gone through a whole range of sources here, everything from, technical specs on voice systems to market analyses on how even your coffee machine is getting conversational AI. We really are moving from a world that was defined by the keyboard's precision to one defined by the fluidity of human conversation.
So let's start with the big question. Why now? Voice assistants have been around for more than a decade. We had Siri, we had Alexa, they promised a lot, and all of a sudden they were just clunky, rigid. Honestly, a bit disappointing for anything complex. So what did large language models, the LLMs, change?
The change was, I'd say, philosophical. It's a move from rigid, rule-based systems to probabilistic, intent-based systems. Siri and the early Alexa, they were basically command directories. If you didn't say the exact magic phrase they were trained on, they failed.
Right. Play music worked, but I'm in the mood for something upbeat would just completely throw it.
Precisely. LLMs changed the entire foundation. Because they're trained on these vast amounts of natural text, they can handle the messiness of real human language. They can infer what you mean, even if the request is poorly phrased or ambiguous.
Can you give us an example of that jump in complexity, from what legacy systems could do to what modern AI can infer?
Sure. Think about a really detailed query. An old system could handle, set a timer for 15 minutes. Simple. But our sources point out that these new systems can handle incredibly complex nested requests. Something like, find me the cheapest direct flight to Tokyo that leaves after 2 p.m. tomorrow but before Saturday, and make sure you exclude any airlines that use the Dreamliner.
Wow. Okay, that's a lot. Multiple criteria, a time window, even an exclusion.
Exactly. A query like that would have just broken any traditional voice interface. It needed structured input that those systems just couldn't process. Because the modern AI can interpret that, voice suddenly becomes the obvious interface. It just cuts out that painful middle step of structuring your thoughts for the machine.
And beyond just understanding intent, the sources we looked at kept stressing the practical side of it.
Yeah.
The speed and the naturalness. It seems obvious, but just how much faster are we talking?
Studies confirm it's significantly faster than typing for most people. But the critical part is that it lets you interact while your hands and eyes are busy. Think about it. You're cooking, you're walking, maybe you're looking at documents on your screen. Voice just compresses that distance, both physical and psychological, between your thought and the system's action.
Which also lets you iterate better, right? I could speak a rough idea for an email. The AI drafts it, and if I don't like the tone, I can just interrupt it. No, wait, make that more formal and address the third point first. I don't have to delete the whole thing and start typing again.
That conversational flow is the breakthrough. With typing, you're constantly editing and rewriting the prompt itself. With voice and modern LLMs, you're collaborating with the system. One of our sources pointing perfectly. Voice-enabled AI is now good enough to compete head-to-head with typing for everyday tasks. And that's the real market signal. We're seeing audio first become the expectation, not the, exception.
So the tech is finally ready. Let's look at the adoption then. It feels like all the major platforms are pushing voice as a core feature now, not just a gimmick.
Oh, absolutely. If you look at OpenAI's own documentation, voice chat is treated as a seamless primary interface right alongside text. It's integrated across mobile, desktop. It's a core feature.
And when you compare the different platforms, the user experience can be really different. What makes some voice AIs feel so conversational and resilient, while others just feel like voice was kind of bolted on at the end?
It really comes down to integration depth and how they manage latency. Sources that analyze systems like ChatGPT's voice mode suggest it feels smoother because it's engineered for really low latency and a high resilience to interruptions. It's designed to almost anticipate human conversational habits. A bolted-on system has these separate steps, speech to text, then processing, then output. The better systems blend those together, so the whole loop feels instant.
And that fluidity is what keeps you using it. But it sounds like competitors are pushing that feeling of naturalness even further.
They are. Take Google's Gemini Live. Their recent upgrades are all focused on making it more like a human dialogue, more natural, and this is key, instantly interruptible.
Right. That's a huge step away from the old, wait for the beep, speak, wait for the response model.
It is. Being able to interrupt moves it so much closer to how people actually talk. You can jump in with a clarification before the AI even finishes its thought.
Does that create a trade-off, though? I mean, making it more natural. Does that increase the processing load?
Yeah.
Or maybe the risk of it misinterpreting you? Especially if there's background noise.
That's the core technical challenge, absolutely. To get that natural flow, you need incredibly robust noise cancellation and much better intent disambiguation. And yes, that means more compute power on the back end, but it seems the market is betting that the huge gain in user satisfaction is worth the cost.
And this voice revolution, it's not just on our phones, it's moving into, serious productivity and enterprise tools.
Microsoft is making a huge play here. They're positioning voice inside 365 Copilot as a primary way to work. The whole vision is using your voice to summarize meetings, draft documents, manage your calendar. They're basically telling the corporate world, talk to your tools.
And it extends right into our physical world, too. Voice is moving way beyond just asking trivia questions.
Oh, absolutely. We're seeing Gemini integrated into Google TV now, so you can just talk to it to find content or change settings instead of clicking through endless menus. And then you have companies like Bosch putting Alexa Plus into smart coffee machines. So you can literally have a conversation with your appliance instead of fumbling with an app. It shows the voice epoch is really integrating into our daily physical routines.
Okay, but none of this works at scale if there's a 3-second delay every time you speak. What's the foundational tech that makes this real-time conversation even possible?
It all comes down to ultra-low latency speech to text. For it to feel natural, the system has to process what you said and start answering almost instantly. Even a half-second pause can break the illusion, and then it just feels like those old clunky assistants again. The sources highlight technologies like Scribe V2 by 11 Labs. These are models built not just for accuracy, but for pure speed turning speech into text in real time, sometimes faster than you can even speak. That's what keeps that conversational loop going at a massive scale.
So voice is faster, it's more fluid, it's spreading from our work tools to our kitchen appliances. It promises this, universal simplicity. But now we have to talk about the critical catch, the big constraint that threatens that entire promise. Why does it affect some users so much more than others?
The promise of simplicity is, unfortunately, heavily constrained by language support. And I'm not just talking about which languages are supported, but the quality of that support. So while a platform like ChatGPT might say it supports over 95 languages, the actual performance, the accuracy, the speed, it varies dramatically from one language to another.
So it's not just asking, does it understand Spanish? It's asking, does it understand it as well, as quickly, and as accurately as it understands English?
Precisely. The performance is just superior in what the industry calls high resource languages. That's primarily English and then, other major Western languages. But for less common or low resource languages, you see lower accuracy, slower responses, more failures. If the voice interface is buggy in your native language, the whole benefit of this voice epoch just evaporates.
Let's break down those terms for our listeners. What exactly makes a language high resource, and why is this bias so baked into the systems?
A high-resource language is one that has a massive, digitized, and easily accessible body of training data. We're talking millions of books, websites, transcribed speeches, all ready to be fed into a model. This data trains both the underlying LLM and the speech recognition part. And, as Microsoft reports confirm, English just has, by far, the biggest digital footprint in the world.
I see. So if you speak a language that doesn't have that giant digital library, the model just has fewer examples to learn from, and that leads to worse performance.
That is the core of the data skew problem. If the model hasn't heard enough examples of a certain language or a specific accent or dialect, especially in a noisy environment, it just can't process it reliably.
And voice makes this even harder, doesn't it? Unlike typing, speaking has all these extra layers of complexity, like you mentioned, accents, background noise.
Exactly. The sources are really clear on this. Voice is significantly harder than text because of all these variables the AI has to filter out. You've got regional accents, different dialects, and a really tricky one called code switching.
Code switching. That's where a speaker might mix two or more languages in the same sentence or conversation, right? That has to be a nightmare for a system designed for one language at a time.
It's a huge technical hurdle. If you start a prompt in English, but then switch to your native Spanish for a technical term and then finish in English, the AI has to track that across both language models in real time. If the model is already weak in that second language, the whole system just fails. It might give you a bad translation or just freeze.
So the practical implication of this for users around the world is enormous. This isn't just some minor inconvenience if the system struggles to understand you.
No, it's fundamentally exclusionary. If the AI can't handle your language or accent well, you face a higher cost of participation. You're forced to change your own behavior. You have to slow down, over-enunciate, maybe switch to another language entirely, or just give up and go back to typing. This creates a two-tiered system where some users get this instant, seamless productivity, and others have to do all this extra cognitive work just to be understood.
And the sources suggest that this problem, low latency, emotion-preserving, cross-language voice interaction, is still an active area of research, meaning that ideal voice experience just isn't solved yet for a huge part of the world.
Which brings us to a really crucial realization for everyone using these tools. Voice prompting is quickly becoming a new form of literacy. We have to recalibrate what skills actually matter now. It's not about how fast you can type anymore.
Okay, so if the thumb epoch was all about mechanical precision, what are the skills that define success in this new voice epoch?
It's clarity of instruction, for one, and the ability to correct and refine what you're saying conversationally, on the fly. And maybe most important, the discipline to actually verify the output. Because there's a critical psychological point here the sources make.
Yeah.
The AI assistant sounds so human, so confident, that it's very easy to just trust what it says without questioning it.
That's a huge point. The system's confident tone can lower your guard because it feels like you're talking to a human expert who knows what they're doing.
Exactly. So our key piece of advice for you, the listener, is to treat voice as an incredibly powerful input channel to speed things up. But you have to verify the output to stay safe. The more human the interface feels, the more your own critical thinking has to increase.
And for the developers, the companies building these tools, the lesson seems to be all about inclusivity. If voice is the next great interface, then language and accent support can't be an afterthought.
Right. They have to be measured on how well they handle the messy, multilingual reality of the world, not just a quiet demo in English. We're talking about the noise of a coffee shop, interruptions in a meeting, a user who code switches between languages naturally. The goal has to be accommodating that reality without forcing the user to translate themselves for the technology.
So to wrap this all up, the major transition we've been discussing is this definitive move from the thumb epoch, defined by precision input, by operating machines, to the voice epoch, which is all about expressing complex intent to direct systems.
It's a profound leap forward in speed and accessibility. But here's the final thought, the provocation for you to consider. If voice only works flawlessly for a narrow slice of languages and accents, we risk building a future where some people get to speak naturally to technology, while others are forced back into that slower, more frustrating world of typing and over-enunciating. The next phase of AI doesn't just need to be smarter, it has to be exponentially more inclusive if this revolution is truly going to be a leap forward for everyone.